Okay, so we are going to start in this class. We will cover what is the end-to-end workflow that a developer do till the DevOps engineer handles. Okay, and this is called the push event, from the push of the developer till the deployment or the deliver to the customer. What all the process includes in between that DevOps workflow. So we'll look into this one. Okay. What will be our agenda in this class? So we'll be looking into this. What is DevOps? Why the DevOps required? What are the what cycle of DevOps? Tools and technology that we have looked. We'll take a deep dive. Okay. What are the tools and technology comes into the picture in between the end-to-end workflow? We'll look into the CI/CD pipelines, version controls, Docker, Kubernetes, logging systems, hands-on project, and whatever the question you have. And the cloud as well, including the scripting. One thing I would expect from you that you take one programming language and you put some amount of work on that one as well. Because no matter how much programming, how much DevOps you know, they'll be expecting a single programming language from you. So I would suggest go with a Python. Okay. Spend at least one question a day or one any concept of Python a day so that you'll be getting very much clear with the other programming languages as well related to this DevOps. I'll be covering this scripting part, but as a programming language, you have to do one programming language from your end. And in that, if you'll face any problem, like if you have any doubt, just reach out to me. I'll cover that one. Okay. So the very first question in any of the interview that you can expect related to the DevOps is like, what are the DevOps cycles? What is the DevOps cycle? Or what is the process of DevOps? From where it start till from where it get end. Okay. So this infinity loop, what it suggests, everything starts from the planning. Okay. You plan what you have to build. Okay. Then you start working on that one using the code. Okay. And once your code is get completed, you put those code in the build tool to generate all the EXEs. Generally, when you install any application, you don't see the code. You see the binaries, right? You see the EXEs, you see the zip files like this. So all these are generated using the code, okay? And then built by these codes are then being built by build tools, which will convert all the codes that you have written into binary format or artifacts. And further, then you have to whatever the artifact that you have get, those artifacts then given to the QA team. QA then analyze all the working or everything is functioning or not. Once QA approve your test, then it goes to the release part. Okay. And the release also doesn't happen once a time. It has a particular date decided. Okay. There are two types of releases, which I will deal in the later classes. So these two types of release basically deals one release that happens every day or the alternate day or every week, and one release that you do in every 3-4 months. So whatever the version of any of the application you see, like the version 3, version 4, this is the current latest version. So these are the main releases that goes to the customer, and few releases that goes to the, and before that, the if you do the releases in alternatively, these releases go back to the test. Okay, that's how it works. And then once the releases get confirmed that everything is done perfectly, we deploy on our main servers. Once it deployed on the server, then operation took place on that one. Okay, what kind of a operation? You have to monitor those servers, then look into those servers. Are those servers working fine or not? Okay, any dependencies left? So all this operation that we looked into that one. And then once we deliver it to the customer, then we monitor throughout the period the application is alive. Okay, we monitor through the monitoring tool. So if any problem comes after that, if any customer raise any problem that we are having problem with your application, then we again see what are the issues through the planning, and again we build code, we build it, we test it, again it goes and the new release comes. Releases may be for all the customers, releases may be for the few of the particular customers. Okay, it could be done in either way. So if any customer is paying you heavy amount and they want that I want a special button on my application, so they'll be paying separately for you, only for that feature. So in that case, you'll do separate release for only for that customer. Okay. And if that customer faces any problem, then you will do some hot fixes. So what is the term hot fix actually means? I will cover it. Okay, no need to worry. But any confusion in understanding this loop? Any question?
No, I'm good.
So you'll be started asking from the question like, what do you understand with the planning? What are the tools you'll be using? So they'll be asking you, what tools will you use for build? What tools will you use for the test? And here, this picture comes into the play. So if we start from the planning, then it could be done in the documentation wise, okay, or you create a lot of sprints for the this coders developers. Okay, I'll show you how it looks like on one of the tool. And once the coder get the idea that I have to do this and this, then the coder starts working on it and push everything on Git. It could be Git, it could be Azure DevOps, anything. But on one centralized repository, they push the things, which then comes into the build tool. Okay. Coder first build it locally, and once the build is successful locally, then only they are allowed to push. Once they push, this is known as PR, pull request. Okay. So being a developer, I'll start from the developer. Okay. I'll behave like a developer. I'll do the work as a developer, and then I'll push my code, and you can see what are the things we do afterwards. Then the things comes into the testing part, JUnit and Selenium. Selenium is for Java, JUnit is for this JavaScript stuff. So these are the two of the testing tools. For Python, you have NPM. Okay. Oh, sorry. For Node, you have NPM. Means any web-based application, if you have, you can use NPM for that one. For Python, it's pip. Okay. So likewise, for C++, Incredible. For every different programming languages, you have different build tools for that. And then comes the releases. So CodeShip and Jenkins is the most famous one. Jenkins is a very famous one. From where we build our codes, we deploy it, everything. Okay. And then after we go into the deploy section, where Docker come into the picture, is converting your releases into the container. Once the container, you can deploy it on AWS, you can deploy it as a container as well. Okay, once it goes to the operation part, Ansible or Kubernetes, these two take care of. If you created container, so container will be taken care by Kubernetes. If you deployed on any physical servers, that will be taken care by Ansible. Yeah. Okay. And then comes the monitoring part. So Nagos as Splunk, these are the other monitoring tool as well, Datadog. But the very most famous one is the Prometheus and Grafana that we will cover. So these are the tools that uses in the different stages of DevOps. Any questions?
Are we going to learn all these tools?
So for every stage, we will learn for this one. For code, we will be looking into this Git, okay? Git and Azure DevOps. For build, we will look into node build is a very famous one. So we will look into the NPM part, okay? For testing, we don't do actually. This is the whole QA part. So we are not going to look into this one. Releases, we do the releases. So we will look into the Jenkins, okay, complete end-to-end part of the Jenkins. Deploy, we will look into the AWS and Docker. We'll go deeper into this one. For operation, we'll look into the Ansible and Kubernetes because Ansible and Ceph are almost same. So there's another one is Puppet, but the most famous one is Ansible. So we will look into the Ansible and Kubernetes. And for monitoring, we will cover Prometheus and Grafana. Okay. So for every stage, one or two tools we will cover. Okay. The most important one.
Uh,
Okay. Any further questions related to this one?
One question.
Mm-hmm.
Uh, Now looking towards DevOps perspective, what
Mm-hmm.
in this cycle, what exactly it's important, more
Mm-hmm.
important? You can rate it as a percentage wise. Let's say 60% of Docker
Okay.
and Kubernetes
Mm-hmm.
is important. In that sense, can you please put some
Yeah,
light
yeah.
on?
Okay. So this is wholly, there are thousands of tools in DevOps, and every organization has their specific based on the code they use. Okay. So if I start from the planning, so all the planning does in the documentation wise, and they put the chart on the Jira. Okay.
Hmm.
So Jira is basically a platform where you will find what are the developers is getting what type of task. So you define the all the task and everything on Jira. Then what happens once the code is being done, Git is like 90%. Okay. There is other tool TFVC, which is not more in use. So almost every company is using Git. Okay. So you have to know Git for the coding purpose. If you have to push everything, push any data, if you face any challenges in Git merge or Git conflict, if you have. So as a coder, as a developer, or as a DevOps engineer, this is the very first task. Because if coder get face any problem in pushing the data, they'll reach out to you. So you should have their knowledge. Because as personally, I have faced a lot of issues or I have solved a lot of issues of developer who were facing in problem in Git. So initially we were in centralized version control system, TFAC, which was of Microsoft, and Microsoft now is deprecated that one. So the only tool left with is the Git. So Git is 100% asked. It's fully important for this coding purpose. Build tool, it will be separate from organization to organization wise. They'll be not expecting you to know the very specific one. Rather, they'll be expecting you that what are the tools, what build tools you know. Okay, because every company is depending upon their programming language having different build tools. So if you know their tools, that's good. Okay, but they'll be not expecting such things. So this is 20 to 30%. It's not a big deal. Okay. They'll be just knowing, wanted to know whether you have idea about build tools or not. That's it. Then the testing part, this is generally taken care by the QA team. So you have no role in this one. Okay. Once the product build, you have to put that product on a one server. From that server, QA will come and take that product and do the testing on it. If the
Okay.
testing get confirmed, okay, if everything works well, then the QA gives thumbs up and then release part comes into the picture. Once the QA gives thumbs up, we'll release it on Jenkins. So Jenkins is very important. It's like 70 to 80%. They'll be expecting you from the release part that you should know Jenkins. Then comes our deploy part. So if the company is microservices based company, means if the company is distributed their application in a very small segments, so there there'll be 100%. Mostly the companies which are web based, where website they are handling or any kind of a web part they are handling, they'll be using Docker for sure, 100%. But if they are using desktop applications, okay, then the Docker use might be very minimal. Okay, because the customer on Docker, our main objective of using all this tool is to provide seamless access of our application to the user. So where we can expect unexpected kind of a traffic only on web. Thousands of people can come and access our website. Okay. But on desktop application, you have one application for one desktop. So there, the chance of getting over traffic is very less. And that's why people who are mostly dependent upon this, having this desktop application, they generally do not use this Docker. Like our organization does not use it because we have this desktop application. Okay. But if you have percent, you are going to use Docker. So this is, if you are using web-based application, will be 90% expectation from you that you should know Docker.
Okay.
Okay. And if they are using this web-based application, there's a chance that they'll be using cloud too. Okay, everything on-premise is very difficult to handle. So mid-size company or even the large size company having some kind of there's some components on cloud as well. So 70 to 80% cloud is necessary for you. Okay.
Mhm.
Then we coming to the operation part, Ansible and Kubernetes. If Docker is being used, Kubernetes must be used over there. Okay, not necessary, but the chances of using Kubernetes increases. If you have huge amount of traffic in your web-based application, then you'll be expecting. One example I can give you, any match, for example, cricket match happens. So you can see crores of people comes and suddenly they comes. It's not that it's been decided.
Yeah.
They know that people can come at a very huge amount. So the traffic will be huge and the access of our application will be in huge quantity. So I
Mhm.
need to have some kind of setup which will distribute my application on thousands of server instead of one server, because
Okay.
you cannot have a single server which can handle crores of people or lakhs of people. So you need to have a auto scaling feature which we will look. So if they'll be having a very good Kubernetes guys in their organization, they'll be easily able to handle such an amount of crowd. And recently, one cricket match happens where Sony was handling and taking care of that one, and they were facing a lot of lagging.
Mhm.
All the customer faced a lot of lag, and few of them posted on LinkedIn as well. Then Sony replied itself, yes, we were having some issue with auto scaling,
Mhm.
and we were unable to handle these many clouds. So yeah, these many peoples. So if you are facing lagging, it means they are not able to do auto scaling correctly or load balancing part.
Okay.
Okay. At the same time, we have Ansible, they'll be expecting 60 to 70%. And if they're using Docker, they'll be, if you know Kubernetes, it's kind of a starter for your resume. Okay. If you know in depth of Kubernetes, it's everything. So because of its complexity, people avoid this one, and very genuine few peoples are there who actually knows the Kubernetes very well into the in-depth one. Okay. Monitoring, they'll be not expecting much from you. But if you know monitoring part, 40 to 50%, I can say. Prometheus and Grafana, if you know, it's a good for your resume too. Okay. I hope you got the answers. Any confusion or any questions?
No. So,
All clear? Mhm.
in the deployment phase, you mentioned all the um, tools for web-based. Am I right? Web-based apps.
This, yes, web-based.
Any.
Generally, mhm,
Okay. Okay. Go on. Go on.
generally in desktop applications, so we have on-premise, so we have few of the servers where we deploy our application. Okay,
Okay.
so those are the main servers. Every time whenever the build happens, we configure in the build that once the release is happening,
Mhm.
build I'm saying, so you can understand release build is also there.
Mhm.
Two kinds of build happen. Okay, one is the product build, other is the release build. So
Mhm.
when release build happens, we put the stage or the kind of location where the exe or the artifact that get generated has to get deployed. So
Mhm.
generally in desktop application, we deploy on a physical servers. But if I have this web-based application or cloud application, if I'm using that, then they deploy it directly on AWS or Docker. Yes.
Okay. So,
What was it?
no need uh, a tool for desktop applications.
No, no, there is
Oh,
no requirement of that.
okay.
Okay. If you have this Docker or AWS, you can deploy over here. Okay. Or there are other cloud platform as well.
Hmm.
But if you are not using any of the cloud platform, the only option left is your on-premise. And
Okay.
on-premise, you have those physical servers. You deploy on those servers. So
Okay.
we generally deploy on physical servers.
Yeah.
We means our organization.
Yeah.
Any confusion, Sujata?
No, good. I'm good.
Great. So these are the few things that started from the history. Okay, it started as a waterfall model, then it goes to the agile methodology, and then currently it is this method is known as DevOps. So waterfall model was very pretty simple one. Okay, you build, you test, you build, you code, you build, you test, you deploy. So everything is just like one way. You cannot reverse go back and do it again. That was the problem with the waterfall model. Okay. So it's a very linear and sequential approach. Each phase here, each phase, mid phase depend upon the previous one, or the even further phase depend upon the previous one. So it's like if any of the phase get destroyed or not working, every phase will be stopped. Okay. Because of this, it was a very slow process. Okay. Automation, there was almost none. People were unable to do any automation in that one. And customer feedback. So you cannot provide customer if customer is having problem with once your product is built, customer is having again problem with that one. So putting that into the center part of that any process, it's very difficult. So again, you have to do from the starting part. So again, if any problem in the monitoring stuff, any problem in the container part, again, you have to do from the starting. So it was a very, lame process and people were unable to do a lot in this waterfall model approach. So it's very a sequential approach. Okay. Mm, So any confusion in this water model?
Nope.
So it's a very sequential model. You cannot go previous further any deliverables dependent upon your previous one. So if previous one get stopped or due to any reason, then the further everything will be stopped. So this problem was solved in the agile methodology. Okay. So highly dynamic. Okay. You can start from anywhere. That's a good thing. Okay. You can take the customer response. Okay. This was included. You can have the customer response. Okay. Before the next step happens. Okay. So here also again coming back to the same cycle is difficult. But what we used to do instead of taking the feedback directly at the end of the project, here we are taking the feedback on every sprint. Okay. On every sprint, what do you understand by sprint? Means a phase. In every phase, we are taking feedback from the customer or from the lead that is that okay? And then we proceed with the next step. So this feedback loop actually help us to modify our this cycle of DevOps more. And with this one, the chances of error get reduced. Okay, time we started delivering everything quickly. Okay, scope and schedule. If we look, so this come into the picture in 2021. Still, it is available, but people go with the DevOps instead of Agile. Okay, adjust scope to preserve schedule it. So you have some schedule here. Adjusting schedule was very difficult, but here you maintain all the schedule dates for every process that this process will be done in this particular time. It's like this. Even now also in DevOps, this is being followed. Automation, some automation we can include. Okay, few of the automation were included in this one. Issues are identified after every sprint. So since there is a feedback loop is there on every phase, so issues, whatever the issues we face in any stages, we can identify and deal with that one. Okay. So here multiple teams are involved. Okay, but not all. Multiple teams in the sense the team which done the previous job and the team which is going to take over the next job. Both the teams are involved, but not from the starting team. Okay. Variations in this XP Scrum. Basically, this Scrum model is also known as Scrum model. So there's a one person known as Scrum Master. So this master is responsible for taking every sprint, delivering the task okay, for what has been done in the previous sprint and what will be done in the further sprint. So this is the task of Scrum Master,
Okay.
which is getting automated in your DevOps. So we looked into the DevOps, okay. It is again agile methodology, okay. But here developers and the operation team both comes into the picture. Here you do not have any interaction with the developer. But here as a DevOps engineer, you have to interact with the developer as well. Okay, related to the push event, git issues, okay, about the pipeline cycle as well. If pipeline build is getting failed, developer is responsible for that one, or DevOps is responsible for that one. Everything you have to look into that one. Okay. So it's an end-to-end life cycle. You can figure out issues in any of the phase, and you can directly switch back to that phase. Okay, there is no problem to switching back to any of the phase. Okay. If you have issues with the release, go back to the tester, tell him that this is the issue. I want to release back it again. Just figure out with the developer. Tester will contact the developer. Developer do all the testing, all the coding stuff again. Do the testing with the developer, and then again come back. Product will come back to you. So everything is being highly responsive to the business model again. So most anticipated in the business. Time to the market continuously, here you are delivering it. Here you are delivering one time in a very quick uh, less interval of time, but here continuously, once you deploy it, you have to maintain it continuously. Okay, that's why it is known as continuous deployment, CD part. Okay, then automation, every phase is included automation. I'll show you what are the automation I have done on my organization. Okay, so every phase includes some kind of automations. Customer feedback, there's a continuous feedback, because your once your product is deployed, it will always remain in this customer's hand. So you will get the continuous feedback from the customer, and you can improve your cycle again and again. Quality, high quality compared to these two. Okay. All the stakeholders are involved from start to finish. Okay. From the developer is doing the code till the product is getting delivered, all the stakeholders involved, the collaboration part. Okay. So when you go for the service-based company, generally, service-based companies, client will be asking you, like, do you know the Docker? Do you know the Kubernetes part? So, client is very much involving in this stuff too. So they'll be taking care of all the phases. And then variation, CI/CD or DevSecOps. Furthermore, GitOps comes into the these are the real ops, also one of this release and operation part together. Any confusion in understanding this approach, just being started from the 1970s until it is continuing? Understood all? Okay.
Yeah.
Yeah.
So one of the basic interview question could be asked, how do you understand with this waterfall model? What was the drawback of waterfall model over the agile methodology? Or what are the other benefits we get in DevOps compared to agile? So this could be a theoretical question you can expect in an interview. So we will cover this one. Okay. How do we have to answer? And what are the scenario-based question can be asked from this part?
Mhm.
So this we looked into for every stage. What are the tools and the technology we'll be using? Okay. Now the flow chart. Okay. Starting from the developers till it is getting deployed, what are the chart is being followed? The very first task is the developer push their code on your repository. Okay, whatever the source code repository you have, developer first push the code into that one. After that, once the code comes, it either comes into the GitHub or the Azure repos. Okay, these are the two repository. GitLab is also there. Okay, but for now here I'm taking Azure DevOps in GitHub repository. If the PR first, whenever you raise any push code, directly that does not go and merge into the main branch. It first gets some approvals. So PR validation is, it goes through. If the code is good, PR is validated. Then it goes to the next step. If code is not good, PR, and who validate this code? Any idea? Developer push the code, but who will validate it? The senior developers. Okay. So whosoever the developer, I'll show you. So if I go here, pull request. So see, there is a one pull request. Okay. I'll take a photo of it. Active. So here you will add the reviewers. Okay. Required or not required. There are a lot of reviewers. Suppose I add myself. So until and unless I'll not approve, this code will not get passed. Okay. So PR is raised by this developer, but there is a one condition that it has to be validate. It does not has to be any merge conflict. Okay. And few more depending upon the kind of organization. If they want more security before merging this PR, PR means your branch into the main branch. So if you want few more validation between that, you can add it. Okay, you can add some tag or work item too. So one has to validate the code before. So this person will go into this file and will look what are the changes being done. Are the changes good or bad? If the changes are not good, he will simply come and reject this review. Okay, approve and rejection is from here. He will simply come and reject it. Okay. Or if it's good, it will, this guy will approve it from here. And once it get approved, it will simply go and merge into that branch. Okay, any confusion?
These are Git
So,
actions or something else?
sorry.
Git. These are Git
That was
actions.
Git action. You can't say Git action actually. Git
Oh,
actions that comes under GitHub actions, not Git. You can say GitHub actions.
okay.
Okay. So this was Azure DevOps action. Okay. Because the platform that I showed you was a Azure DevOps platform. GitHub's having the same. I'll show you when we'll do the Git and GitHub class. I'll show you over there. Okay, how it works.
Okay.
So PR got validated, and then once it got validated, the build start. This happens automatically. Okay, the moment PR is validated, build automatically will happen, and it will generate your zip file, DLL file, all the dependencies, all the exes, artifacts. Okay. Once it get developed, build is happened, then it goes to the CD part, that is the continuous deployment part. But generally, this stage is manual. Okay, it's two-way things. One is manual, one is automated. I told you, deployment or release, there are two types of release. One release is per day or every alternate day. That is the automatic one. But the release that you do directly to the customer, that one is a manual. And before that release, lot of discussions happens. Okay. So before continuous deployment happen, that is the per day or the, you can say the alternative days, whatever the release build is happening, there is a pre-deployment approval. Pre-deployment approval means the main release. When main release is going to happen, some approvals required from the from the manager, team lead, or the brand lead, whosoever handling the project, those leads, and they will notify through this email or Slack or any kind of a run. Okay, generally email we follows. Okay. Once, so before this pre-deployment, everyone is said a final QA test is being done. Okay. This test also happen after the build. this stage 2. This QA part also happens where all the unit test is getting tested. Okay, what are the edge conditions of the code? Everything is getting tested over here. Okay. Once it done, auto approval happens. Okay. Approval gate is there. Okay. This is the production approval gate, which seems like blue, green, or canard. This is the method of doing the release, which what does it mean? I'll show you in the later classes how the release happen. What is this blue, green release? So basically in this release, this is a continuous release. So every time your website will be up, even though if there is a problem with the current version, still you can go back to the previous version and you can make it live till you solve the problem in your current version. So that is the blue-green release actually. So once everything is being done, deploy to the production is being done, then we do the monitoring, continuous monitoring on the deployment part. So whatever the feedback coming, server is working well or not, all the containers are healthy or not. So everything we monitor, or if a huge amount of traffic is coming, how we are doing the auto scaling, load balancing. So these things are the post deployment task that we take care. So this is the whole figure that our DevOps goes into one by one. Okay, and we will cover the whole steps.
Okay.
Any question in this flowchart?
Can you please quickly go through CI stage and CD stage again?
Yeah, sure. So CI basically, once the approval is done,
Mhm.
a build will run. So I'll show you that. Once this approved is being done, so if I go here, I go to the PR. Let me see. These are the active PRs completed. I'll go to the completed. So you can see this is the completed. No merge conflict is there. Approval is being done by the two people. These two are the developer itself. Okay. And further, no merge conflict. Approval is being done. Means all the check is done. So what happens? The build take place. The moment it is done, the build take place. So where you can see the build, you just come to this pipeline. So once
So
those approvals are done,
after the approval, it will come here.
this build automatically get triggered.
Okay.
Okay, you have to do that setting so that whenever approved is done, the build automatically get triggered. So this build 4 hours ago automatically happens once that approval is done. So you can go through this build. Either it could fail or it could pass. There can be two scenario. If it fails, okay, you will have to contact you have to see the reason why it get fail. Is it because of my issue? And what could be your issue? Server space is not there, or any server is not working, or server got expired, or any year of the DevOps, this one pipeline is getting broken in somewhere. This is the your issue you will handle. But if you have to see the code of the issue, is this the code related issue? If it is code related issue, you'll have to go back to the developer and tell him that there are some code issue that you have to take a look into it. That one. So again, will developer will look into that.
Okay.
So you just go see every stage is passed or not. So this is a build, okay, where stages is being defined.
Mhm.
This is automatic. Okay. You have to, as a developer, you have to build this stage.
Okay.
Okay. And make it more compatible for the source code. This is the task. And you can do it in YAML file or in PowerShell script, anything you can use.
Mhm.
So this is the CI stage, continuous integration. Means you push the code, code get approved, automatically build got trigger.
Okay.
So this is the CI stage. CD stage, this one, the CD stage, it happens. This is same like the CI, but here we are what? Building the zip and all. In CD stage, we deploy our whatever the build happens over here, we deploy it on the server.
Hmm.
this build with CI, you only build the artifacts, binary files, EXEs, DLLs, okay, zip files. But once that build, they remain on the platform. Okay, suppose this one got built, so it is remaining on the platform. You can see this is the output. So zip file got created with that code, but QA will not come here and download from here. Okay, you have to run a release build from here. So what is the task of release build? Release build put your exes or whatever you have generated, that zip file, into the server. Okay, and from that server, QA people will go to that server, and from there they will take out that zip file and run it on their local machine and see all the functionalities are working or not. If it is working well, then only they approve for the next stage.
Yeah.
And that is known as CD part, continuous deployment part.
So in the CD part also QA role comes
No, QA role comes after the CD
after
part.
this. Yeah, after this. Sorry. Okay.
Okay, this one is the email notification that you provide that the deployment happens. Here comes the QA role. QA will go take out your all the artifacts of binary from the server from where you have deployed it using this step, continuous deployment. That is the release stage. And then QA will test it. If everything is fine, then QA will approve for the further main release. Okay. The main release happen in this scenario, blue-green scenario, Kenar or deploy to the production. Deploy to the production means deploy to the server from where the customer can take. Okay. And then you do the monitoring stuff. That
Okay.
if you have thousands of new customers are coming, you have to take look every time look into the server. Is it getting over used? Or the server space is there or not? So these things is your task. Any question?
Is there any difference between Azure DevOps and AWS DevOps?
There are huge difference. See, Azure DevOps and Azure is different. First thing,
Yeah.
Azure is a cloud. Azure DevOps is not a cloud. Azure DevOps is entirely a different platform. Okay. So Azure, this one is a cloud. Okay.
Yes.
Azure cloud. If you see, symbol is different. Even the UI, everything is different. Totally work is different. But Azure DevOps that I showed you over here, this one is doing multiple tasking. For example, if you this repo part only handling all the GitHub tasks, means it handles all your repositories. I can see the history of the repository. I can see the content of what are the files, what are the codes. Okay. So all the GitHub is being under this repo. All the Jira part is under this board. Means all the work items, sprint, everything I can create over here. All the Jenkins is inside this pipeline. So I don't have to go and create a build in Jenkins. Instead, I can use this stuff. Artifacts, you have to generally people store artifact in JFrog as well. But here they have given you space for artifacts also to come and store your artifact. So it is a combination of 3-4 tools together. Azure DevOps. Whereas Azure is a cloud which has a different purpose. Okay, there you can't do all this stuff. You can't do the sprint part. You can't create the pipeline over there. Okay, that will be a totally different one. Just like AWS. Azure, AWS, GCP is different. It's cloud one. Azure DevOps is a different tool. Okay, which handles all your multiple 2-3 tools tasks at a time. Got it? Still any question?
Mm,
Clear now? What is this Azure DevOps? Both are different. Okay, Azure DevOps is different, totally different. So we are using one part of Azure DevOps, that is Azure Repos, GitHub, Whole GitHub and Azure repos are same. Okay. Whole JFrog and Azure. This was the name. Board. Whole Jira or this Azure board is same. Whole Jenkins and this Azure pipeline is same. Okay. So people, when they don't have to rely on 3-4 tools, they go for this Azure DevOps. Okay. Because you are getting everything in a very simple UI, easily handleable. Okay. So people go with this Azure DevOps. But some people who are very much dependent upon the other tools, they don't want to switch on this one. So they continue with those different tools. Okay. Because once this Azure DevOps is down, you will be down with all the services. But if you are handling independently all these services, then even if one service is down, you can work on the other service too. So that's the only benefit you get.
I'm just asking about Azure and AWS because I'm aware about the AWS concepts, not
Mhm.
Azure. So
So
will
you are
you
asking about Azure Cloud, right?
Yes.
So you want me to cover that Azure Cloud? I can do that one. Okay. Because the thing is, whatever you have seen in companies will only expect you a single cloud from you. Okay. Either you have knowledge GCP and this Azure, you keep the knowledge, but
Hmm.
on one of the cloud, you should have the master. That is the thing they will expect from you. Okay. Because you don't know what organization is going, what kind of a cloud they are using. Okay. If you're doing mastery on all three, that's very good. But if you do even on one, then that's good to go. Okay.
Okay.
And majority of the market is being acquired by AWS. So it's better to go with the AWS. Still, I'll show you the UI part and a quick review of this GCP and Azure. Okay. So you should have the idea that how it works. Not going into the depth of that one, but I'll show you how both are looking like. Okay.
Okay, no problem.
Yeah. That's all for today's class. Any question, guys?
Nope.
Mm.